Hey everyone, thank you so much for watching the Weaviate Podcast. I am incredibly honored and grateful to host these guests on the podcast. This topic will be absolutely epic. Firstly, we welcome back Weaviate Chief Technology Officer and co-founder, Etienne Dilocker. Etienne, thank you so much for joining the podcast again.
Thanks for having me.
And of course, I am beyond excited to welcome Farshad Farahbakhshian, a Principal Solutions Architect at Amazon Web Services. Farshad, thank you so much for joining the podcast.
Hey, thank you so much. And by the way, my title here is actually Gen AI Specialist, but a lot of times people think I'm a solutions architect, so it's all good. Nice to meet you all.
Sorry about that. So could we kick it off with I think maybe some for our newer listeners, could we maybe even start from the beginning, Eddie? And if you could kind of just what is Weaviate, even just kind of Weaviate and the evolution of it that's led us to this point of talking about with AWS about running it on the cloud and kind of how far the journey has come.
Gotcha. Yeah, sure. Let me try to keep this brief so I don't fill the entire podcast with this. And hopefully, so on the self-hosting part, we can definitely dive deeper into that later in the security, privacy, et cetera aspects. But basically, Weaviate is a vector database, or for those of you who don't know what that is, it's essentially the long-term memory for large language models. So for retrieval-augmented generation, for example, definitely something that we're going to dive into, I guess. And Weaviate is an open source vector database. You can use Weaviate as a SaaS offering from us. So that's our Weaviate cloud service. But you don't have to if you don't want to. If you don't want to give your data away, you can self-host it, or you can help us help you host it in your environment, in your cloud tenant, in your VPC. And that's one of the USPs of Weaviate, because that allows you to stay in control over all of your data. And then if you have that, you can query Weaviate with vector search, so dense embeddings. Use dense embeddings for the modern day retrieval. You can do the classic stuff. So BM25, you can mix it with hybrid. You get all kinds of other database operations and all that at great scale. And yeah, that was my elevator pitch.
Yeah, I think that's awesome. I think just, this core of this HNSW vector index doing, fast nearest neighbor search is, and then especially with this retrieval augmented generation, I think this has caused just a boom in the explosion of how often people are using these kind of things. So Farshad, can you maybe tell us about kind of how you see the state of vector databases and retrieval augmented generation?
Yeah, I mean, at a high level, most customers that I talk to, they're like, "Oh, we just want to fine tune everything," right? And fine tuning is great. It's how you teach your model new skills, but it's not necessarily the best way to have it know knowledge. And so vector databases is the most reliable way to do that. And so one of the most common use cases that we see is, hey, here's a really simple one, right? Like we want our customer service agents to be way more efficient, right? And we want them to very quickly go through a very relatively large knowledge base and retrieve precise information. There's honestly not much reason to do fine tuning there unless you want your language model to sound different in how it interfaces with those customers. But if you want to retrieve specific info, like something in a data sheet, vector databases are very powerful for that. So pretty common architecture that we see come up is a strong LLM plus like a Weaviate vector database combined to offer that solution.
Yeah, it's amazing. The chatbots thing, the whole chat with your documents, chat with your specific customer tickets, I think is just, an incredible evangelist for all this. And yes, I think we've kind of set the stage of what the technology is. Weaviate vector database helps you retrieve relevant information to put in the context of LLMs. Let's get into the super exciting topic that, we have our special guests, our technical experts on. What does it take to run this in the cloud?
So a couple things, right? There's so many ways of doing this in the cloud right now, right? So I'm going to go top to bottom, right? And let's kind of view it as I view the LLM as kind of like the center that everything goes around. If you want to work backwards from a proprietary LLM, like say from like an Anthropic or a Cohere, you generally are limited to however the cloud provider lets you access that. In the case of Amazon, we have a service called Bedrock. What Bedrock is an API service that lets you do prompting and, depending on the model provider, actually fine tuning as well, right? So you have your API portion of that. What's interesting about Bedrock is that we never share the data or the prompting to the model providers. So what's kind of interesting is that even though the model providers say that they will never use the data, our customers are like, yeah, but we still want someone in between, right? So that's why Bedrock is one of the value propositions, right? So you have your API call, goes to the model hosted on AWS, but you can't access the weights. It's all opaque. And then around that is when you have to start thinking about like, well, what I want to do on top of that, right? But in parallel to that whole thing is you have open source models. Llama 2 just came out, right? I think it was last week. Llama 2 is doing really well, right? And it's also open source. With something like Llama 2, you can use services like Bedrock. You can also use services like Amazon SageMaker Jumpstart, which the difference between SageMaker Jumpstart and Bedrock is that it's not serverless. Users have to actually manage infrastructure as well. But some people like that. Some people like having more knobs to control. You can also fine-tune Llama 2, right? So now, once you start getting into some of these models that fine-tuning is a part of it, some people like to have data engines that they incorporate RLHF into it, right? So here's a really simple example. A lot of folks that build diffusion models, the way they get human feedback is they'll give you like 4 low-resolution models, and then they pick the user picks the one that they want to make high resolution, and then now the model provider knows which one got the RLHF, right? So then you have a data engine involved, right? And then this is all using managed services. We also have a ton of customers that want to pre-train their own models. A lot of folks tend to actually do this on bare metal EC2, right? So they'll get your A100s, they'll get your H100s. We have our own proprietary chips called Trainiums as well, which support things like LLMs and diffusion models. And they'll basically take, like, no joke, like up to like 4,000 GPUs in one cluster to train one large job, right? So they get huge. So there's so many different ways to do it. And we're not even going to the inference side of it. But this is kind of like the model piece of it, right? And then depending on how you're going to be using that model, you're going to be interfacing with a vector database, like from Weaviate. And you're obviously going to be using services like S3 to store your data. Maybe you have a data lake involved as well. The interesting thing that is a little bit different on training versus inference is that when you're doing training, all you really care about is like your time to train, right? It's just like train the model as fast as possible. When it comes to inference, all of a sudden you care about how everything plays with each other, right? It's like, how tight does your vector database interface with your LLM? How tight does that eventually lead to your user experience, right? And that's probably just going to be dependent on use case, right? So like, for example, if you have a live customer agent that's having real-time conversations with customers, you're going to really care about latency at that point, right? But if something is like, oh, we have a week to get this response, it's a completely different architecture. So now you start getting into use case dependent architectures that decide whether or not things are going to be good. And then once you start really caring about latency, model distillation becomes important as well, right? You want to get the model to be as small as possible. Some people want to get these models to work on the edge. I can think of companies trying to build, metaverse, omniverse, whatever you want to call it, where latency becomes so important, where I can see a world where you're going to have custom ML chips for inference to host these models locally to just super reduce that latency for those use cases. But anyway, I just talked a lot, so I'll let you ask me any questions about that. But I just wanted to give you like an overview of like, what does this whole ecosystem look like from an infrastructure perspective?
Yeah, I'd say quickly I mean, first, I thought it was a really great overview. I loved hearing all. I mean, I think I first heard about like SageMaker with some of the stuff that Hugging Face was doing, like kind of for me personally, like, coming out of my PhD in machine learning and starting to like learn about what the products are and how this really works in the real world. And yeah, the Bedrock API, there's just so many interesting topics. I think, maybe it would be great to kind of just talk about that integration between LLMs and vector databases a little more. Just like maybe Etienne, you could explain kind of how we design our generative modules and sort of how we think about that kind of thing.
Yeah. Specifically, I want to start with something on that part. You mentioned the training objective of training this potentially as fast as you can train it. And I assume that the cycles in which you would retrain, they're relatively slow, right? Or relatively long cycles. So I'm curious, sort of, how does the ability to change your retrieval algorithm, or not your algorithm, but your retrieval system on the fly, like, does that sort of be before, if you wouldn't do retrieval augmented generation and you would potentially have to retrain your model every time it has to get new knowledge in. So how do these cycles differ, and when do I use what, basically?
Yeah, that's a super cool way to categorize it, right? Because what we're starting to get into is like, now we want to have a categorization and intuition for what do you want to train for and what do you want to use a knowledge base for. I was on a call with Anthropic last week, and I really like the way they think about it. They split it into skill versus knowledge, right? So if you start to think about, like, what is a skill versus knowledge, right? Let's use the lawyer example. A skill that a lawyer has is understanding the law. The knowledge that they have is recalling different laws, right? So you're definitely going to have use cases where you want to build your model such that it builds an intuition for what it's doing, but you don't want to train it to understand every single law out there. It's pretty inefficient to do that, and it's probably not reliable, right? So if you feel that, and if you categorize it into those two different buckets, my thought process, my intuition tells me that you can do way less training, right? Because if you try to use training to have something be knowledgeable, I mean, all you can do is like approach what you could do with a vector database. Even then, you could never be fully as reliable as a vector database, right? So I would say if you're building an LLM, um, categorize it into those two things. Once you feel that your LLM has the right skill base to sound like what it needs to sound like, whether that's a customer service agent or a lawyer or a programmer, or a musician, whatever that may be, then it's time to start focusing on the vector database. And I'm willing to bet it's like a 90-10 ratio difference, right? If you start using knowledge for vector databases, you could probably do way less training than you thought you need to.
Love this differentiation, skill versus knowledge. This is great. So I'm thinking in my head, when you brought up the lawyer, I'm thinking the lawyer sitting in front of this shelf of books, and the lawyer doesn't have to memorize every single book. They don't have to learn it by heart, because they can just look it up. And essentially that's the retrieval part in this. This is awesome.
Yeah, and I really love just like the separation. I think like kind of like operationally, like if you need to keep fine tuning the LLM, this is kind of one of the first things that drew me to retrieval augmented generation is, if every time you have new knowledge, you need to retrain the model and then rebuild the APIs and all that kind of stuff, compared to this thing where, the vector database is easier to update, kind of like. Well, how do you think about that kind of aspect of it, of how just the retrieval augmented setup, it lets you update it just with way less overhead than kind of maybe a more traditional MLOps thinking of like, keep training, keep training?
Yeah, I mean, I would even take it a step further. I would be willing to bet that for a lot of use cases, if you use a vector database and you take advantage of a relatively large context window, you may never even have to do any fine tuning at all, right? So the vector database is going to eat up a lot of the fine tuning that you traditionally think you would have to do in the past. And we're seeing these models have very large context windows, right? Like today, Anthropic's context window is 100,000 tokens, which means you could input an entire Harry Potter book as your prompt, right? So that, in combination with a vector database, I start wondering, well, you're still going to need folks that do fine tuning, right? Skills, limited things, etc. But I think you're going to be surprised how much you can get away with a vector database plus some good prompting.
That kind of brings up the opportunity to put that training effort potentially into the vector database, because the vector database also uses a retrieval model that commonly, like with the latest models from Cohere and OpenAI and all these models, I think sort of this has been put in the shade a bit. Like people don't talk about fine tuning it as much anymore because they become sort of more general purpose, etc. But before that, I think that was also a very, very common topic about fine tuning those models. And I'm thinking, if you have that skill set in your team to train a model, like potentially put that focus instead of putting it on the large language model, just put it on the embedding model and potentially get better domains for your domain there.
Yeah, like the the search relevance, improving the search, all the knobs you can turn is so fascinating. One thing I really love, Farshad, is you bring up that like long context windows, is this idea of like searching across multiple information sources. Like, you're building like a customer support chatbot, and so it might search through one index of like previous, customer support threads, as well as searching through, say, the Weaviate blog posts, or maybe the code base if needed, but like combining all these different information sources. They call that like federated search. And yeah, I think it just this idea of how you combine maybe like multiple indexes together for retrieval augmented generation. I think that's one of the like emerging frontiers of just, packing that prompt with as much information as possible to complete the task.
Yeah, no, I think you're right. I just actually learned about this recently. I saw some block diagrams of how this is done on the LLM side. The LLMs look like they're on a trajectory to know which database to go to do different things, right? So they're gonna like have an understanding of the question, and then have like a probability of what each database is likely to answer this question, and then go to that database, right? Which is interesting because I think that's actually a little bit different architecture than before, right? Previously, a lot of folks would like just go directly to the data and then give that to the LLM to generate an answer. But now it's kind of the opposite. Now you have an LLM accepting the prompt, understanding it, deciding which database, which vector database, for example, to go to, and then generating a response, right? So that's really cool. Like we're starting to enter like, oh, this thing feels very intelligent, right? So I really like that. And I think in general, the analogy that I like to think about that we're going to eventually go towards is like the human brain, where I have different parts of my brain to do different tasks, right? There's a part of my brain that does math, which is probably not the part of my brain that feels emotions. And that's probably not the part of my brain that recalls information, right? And so what you start to look like is you're going to probably want like something that has logic to know what part of the brain to go to or which LM to go to. And then this example we're talking about feels like it starts to approach that, because while it's not different LLMs that it's going to, it's different knowledge parts of, let's call it the brain or the, whatever that it starts to go to. But if you can have something know where to go for different types of questions, there's nothing preventing us from doing the same thing with LLMs in the long term, right? Hey, this is a math question, go to the math LLM. And the reason why that's important is because your brain would have to be so big if it didn't have efficient, smaller parts of your brain to do things. And to make that analogy with LLMs, it's like we can create much more efficient models over time and it create real products, right? There's going to be limitations of cost and compute for specific use cases unless we get these distilled smaller models to do very specific tasks, right? So I think it's really exciting to hear about this new architecture type.
This reminds me a bit of that question of whether a hybrid search is potentially zero shot or few shot, because in hybrid search, in our case, we have one parameter that can be tuned, and that's essentially this alpha parameter that tells you give more weight to either the embedding based search or give more weight to the keyword based search. And if the model has some reasoning, like potentially it could narrow this down already. It could say like, hey, this looks like a brand name. I'm probably going to want more of a keyword match or something, or just like a product description or something. So this could be a move in that direction as well to sort of give the model, as you say, more intelligence, more domain knowledge about the backends to just use them better and do better retrieval from them.
Yeah, super exciting.
Yeah, that's brilliant, Eddie. And I love that, like, the LLM that knows how to search. Friends I've been talking to know that I don't shut up these days about the gorilla large language models, which are like, you've, instead of using a 200 billion parameter GPT-4 model or whatever to make Weaviate queries, you train a 7 billion parameter, and then it's much more efficient to run. And exactly what you were saying, Farshad, I agree strongly with this, that there are going to be kind of LLMs over all of the tools that the LLMs know how to control the APIs, like Etienne's explaining with taking a query and saying, should I weight BM25 more heavily than vector search for this one, or adding the symbolic where filters to queries. And generally also, I think just there's kind of two things to it. Like large language model tool use, the tools have APIs, and so the language model needs to behave exactly, format the they call this like constrained output sampling or structured parsing, where it's like the LLM needs to format the request perfectly. So this kind of tuning I think is perfect for that. And I think, yeah, I love the parts of my brain kind of analogy and how each one is smaller, because if it's everything is a large model, then it's like kind of expensive to tune. But it comes into vector databases too, because like in addition to having specialized LLMs to control each tool, you also have specialized vector indexes that contain different types of knowledge. Maybe Etienne, you could talk about, this is kind of a topic that I always love thinking about, is like when to separate my data into multiple classes in Weaviate. Maybe also for new listeners, we could quickly do what a class is, and like when to separate it into different classes, how to think about adding filters versus classes.
Yeah, the original motivation of this sort of class-based schema in Weaviate was to reflect the real world. So in an earlier version of Weaviate, we even had a distinction between a thing or an action that would sort of describe either things or action. That's long gone, because that led to more confusion in the API than it actually helped. But it kind of it's where the history of where the classes come from. Like they were meant to describe real world things. So if you have books, put your books in the book class. If you have I don't know, chapters or something, put them in the chapter class. And that kind of like, I'm already sort of going to the next use case of this, which is chunking up stuff. So for these retrieval tasks, very, very common question or very common optimization problems, basically how small, like what do I obtain a vector embedding for? Do I just create one vector embedding for my entire book? Great if you're just trying to identify the right book. If you're trying to search through your book, that's not granular enough. Do I obtain a vector embedding for every word in my book? Well, great if you're trying to find words, not very good if you're trying to find context, because you're losing all the context. You're sort of going back to the original steps of vert to vec. So they're most likely it's something like the paragraph, or maybe if it's a long book and you're just trying to get a high level search, and maybe a chapter in the book, something like that. And that is something that you can use the Weaviate class model for, to retain that association, for example, between a class and a chapter, between a book and a chapter in that book. And that allows you to, for example, search through chapters, but then make a relation to the book, and then maybe do something with that. So you could potentially sort of make these graph-like connections, even jump to the author that authored these books. And as for your questions, like when should I use these links between objects of a class as opposed to a primitive filter? This is mainly a performance optimization. So a primitive filter is cheaper to run. Weaviate has a bitmap index for primitive filtering, basically, or for building these allow lists for filters. So if you want to get the most performance out of it, it's probably faster to do it sort of on the object itself. So essentially like a denormalized schema in sort of SQL/NoSQL terms. And if you use these links, it's maybe sometimes easier to reason about. So that's kind of the trade-off. Do you want something that's easier to understand versus something that's more performant?
Yeah, amazing. And yeah, just understanding that kind of filtered HNSW, like how filtered search works with the vector index and all that. I think you kind of quickly mentioned SQL with a different perspective, but like this, I think also kind of in our broader conversation of just LLMs that use tools and that, like selecting which class, book chapter, and that's like one kind of LLM query routing task. But there's also kind of like, is this a vector search or is this an SQL search? Like if I say, what is the average age of my podcast listeners? Not that I have a database of how old not that I have that, but like that would be a SQL kind of query, not a vector search query. So yeah, I think just all this kind of routing and, it kind of, like this system architecture kind of thing of like, like, I don't think it's quite the same topic as multi-tenancy, but it's like kind of like how you have all these different classes that you run in the cloud then. And like, maybe we could talk a little more about like, what does it take to, maybe we could actually kind of pivot the topics kind of broadly into just like, what kind of requirements are we seeing to be running vector indexes in the cloud?
Is it okay if I ask a question? So it's related to the question that you're asking too, Connor. I'm really curious, like what has been like the one or two or three use cases that relatively novel, and we're really surprised to see how well it worked while using a vector database to get there. Like, wow, this works really well for this use case, right? Have there been some of those come up, and what were those use cases? What was surprising about it? Was there anything interesting about the architecture to get there?
Yeah, I think initially, sort of, if we look at the pre LLM era, the main use case, because of course vector databases existed before ChatGPT, basically. So the whole sort of using them as a building block for retrieval augmented generation is relatively new. So before that, I think it was mainly just search with contextual understanding. So these like very small differences in the input query, like using the word not as a negation or something. So for example, searching for something that is that has wings but is not an airplane or something. Traditional keyword based matching, it would match for airplane, and then it would also match for not, which would sort of completely mess up the result quality. So I think this was my sort of, for me, one of those moments where like, okay, wow, there is such potential in this. So basically the classical semantic search in a sense. And then post LLM or post ChatGPT, yeah, it's gotten more into all these kind of chatbot and sort of there was this moment where like, wow, this is so much bigger than just semantic search. There's all these systems that I think the first time someone talked to me about generative AI in general, that was way back. Basically, for me, it was a bit hard to make the connection. Like, okay, yeah, that's an awesome field, but I don't think that's a related field. And at some point, there was this, oh, actually, it is, and that was such a. I think that's not an exact answer to your question of what are the great use cases, but the sort of in my personal journey that was one of the things where like, oh wow, okay, there's just so much more to it. And yeah, seeing the first sort of chatbot applications that users do, specifically sort of the chat with your documents kind of use case, that's such a great one. This giving this sort of more interactive kind of feel to it, and then especially if this is like the typical demo cases that you would see, they're always like take something from Wikipedia and this like general purpose kind of general knowledge kind of things. But then seeing our customers implement this on like super domain specific data, like in the financial industry or something, that is so cool to me, because it's sort of these very boring documents where I imagine people spend so much time going through them, like extracting all the information, and now you can automate it, and you can automate it with something as simple as a single query where you tell the large language model, hey, retrieve the right stuff and then do something with it. So that I think was for me definitely one of the eye opener cases. Maybe Connor, maybe you have a couple more.
Yeah, I think probably the biggest eye opener for me, I think, was, Bob was teaching me about, it's called, like, I don't know, I think it's called disruption theory. Sorry, Bob, I forgot the name of this thing, but it's like, but it's like about, it's about like this virtuous cycle of how you kind of like have distribution and customer experience. And so kind of for me, just like that personalization component that's achieved by LLMs, that to me, I think it like, just how I can, go through the Twitter, like we all manage a ton of relationships, right? Like in the technology industry. And it's like, it's impossible for me to keep up with what everyone is doing every week, for example. And so just having LLMs that can like summarize what, like say Michael Goyen and Neural Magic have done this week, and maybe like connect it with what I'm doing and like automatically generate these reports for me, just this kind of like, the personal experience that you're able to give to potential users of your product, as well as kind of like partners and integrations by having the LLMs like combine knowledge sources. That's probably my favorite one. Yeah.
Super cool. And by the way, that was totally a selfish question on my part. I just wanted to expose myself to what y'all are seeing in this space. And yeah, that's super exciting. And I think you mentioned magic. Did I hear that correctly?
Oh yeah, well that's a friend of mine who's the company, he works at this company where they're working on LLM inference acceleration. And it's just like an anecdote of saying like, they post these new updates, like, I don't know what their cadence of how many blog posts they do per week, but let's say they do like 4 per week, and let's say I have 20 such technology companies I want to keep up with, and now it's like 80 in a month, and I can't be expected to read all this. So like that kind of thing, that I think that just helps us connect with each other also, like this kind of like social Yeah, I think that. I mean, I guess like one more thing I really enjoy, just that I've seen, is exactly what we were talking about earlier, where we're talking about searching across multiple indexes. Erica also at Weaviate, she's been exploring like Llama Index has built these really great tools on top of Weaviate as the vector database, and then they're exploring like the sub question query engine. So I ask a question like a Weaviate feature, what is ref to vec, and then it routes the question to one index of blog posts, one index of podcast transcriptions, and then one index which is the Weaviate code base. And I mean, the code base, we could talk about all sorts of things of how you can use the levers of Weaviate to search through code bases. But just seeing that in action, the routing queries to different indexes, that is a mind blowing thing of retrieval augmented generation for me.
Super cool.
Awesome. So, okay, so I would love to kind of pivot our topic into a little more about, Eddie and I'd actually like to kick this off with kind of like, one question I've always kind of found really interesting is like, so with AWS cloud services, you have like all these different machines, and I've seen some things like maybe like benchmarking Weaviate with like different particular machines. How do you think about that kind of thing?
So I assume you're talking about like instance types.
Yeah.
So I think what's helpful in this context is talk about like how do customers go about doing this, and why do it this way? The best way to do this is when you're trying to work backwards from like what's the best instance type for me to do what I'm trying to do with Weaviate. It's just to do a proof of concept, right? So this is something I do pretty commonly with a lot of customers that I work with. We get an understanding of what they're trying to do, like what are some performance KPIs they're looking for, and we'll do some testing across instances, right? So there's so many different instances at AWS, right? Whoever you're working with, whether you have an account manager or like a specialist like myself, they'll be able to guide you on like what are the options to test, maybe narrow down to like 3 or 4 different instance types, and then do some testing, and see where it goes, right? Like sometimes you have, are you focused on, and when, how do I say this? Your use case will determine what instance type you use, and there's really common patterns for specific use cases, right? You have all these building blocks from AWS, and you'd be surprised how often customers end up selecting the same exact instance for a given use case, right? And what that means is that there's a lot of tribe knowledge within AWS. Like when you're talking with someone, you're like, hey, this is my use case. It's like, we're already going to have an intuition for what's going to be best, but we don't want to tell you. We want you to get to that conclusion on your own, right? So we're going to set up an environment for you to do testing, right? Because this is how the tech world works, right? Like we want you guys to make the best decision for you, and we'll help guide you get there. But ultimately, you need to get that data for yourself, right? So that you know, versus taking my word for it, that you've built the best solution for your company, right? So that's generally how we do it. Ask your account manager for credits along the way so you're not paying for it, right? So usually we can do that as well. There's obviously limitations, right? Like you can't have like a 1 year long POC, for example. But yeah, like we're more than happy to help, and that's generally a good protocol to do it. Data.
Great to hear this use case centric nature of it, because this is exactly what we're seeing as well. Like benchmarks are always lying in a sense, that they're optimized for one specific thing, whatever you want to show in that particular benchmark. And I think especially for users who are new to all of this, if all they have is a benchmark, they're just going to pick whatever in that particular benchmark is on top, even if that's not at all what they need. So for example, often benchmarks are optimized for either throughput or latency, which is kind of a similar thing. If you ignore that doesn't necessarily have to scale. Like often they're single threaded, and then you'd have multi-threaded queries and these kind of things. But something that comes up way more often in the discussions that we have with our clients is actually cost. And none of these benchmarks optimize for cost. So the question is like, what is your actual query load? What is your throughput? And then you see that all these curves in these benchmarks, their actual throughput is so much lower, and really what we have to optimize for is cost. And then in Weaviate, that could, for example, mean a turn on compression, which is sort of another latency versus accuracy versus memory footprint a trade-off. But also, of course, machine sizing. Like, do you really need the machine that allows you to I don't know, have 2,000 as opposed to 1,000 queries per second if you have one query per second. And then you get these machines that are optimized maybe for more memory relative to CPU, et cetera. And they're similar as you said, there are patterns. We also see these patterns, like either you're very sort of on the throughput side. Then on AWS, I think this is typically what we see is like M6i or R6i machines, or maybe you're more on the operating cost side. And then we see more for example the I think M7G or so the AWS Graviton, I think they're called. So long story short, I really like this. It's so like, yes, of course we would like to tell our users, yeah, just do it like that or compares like that. But really, if you want the best possible infrastructure setup, you just need to adjust it to your use case, because every use case is different.
Yeah, I totally agree. It's such a, like, honestly, a distraction to be like, oh, this is the best thing for this. And the best customers that I've worked with, and when I say best customers, what I really mean is, what are the customers where I'm like, wow, I would join that company. I really like the way they're doing things, right? So the customers that I'm considering best in that context, they don't follow benchmarks. Like, they go down to what matters for me. And going back to like the AWS perspective, 9 times out of 10, price performance is the name of the game. So not just performance, not just price, but price performance, which really means going down to your use case, right? Where am I getting the best bang for my buck? The only time price performance is like been kind of deprioritized a little bit is if security gets involved, like a security standard where we definitely can't use it this way, even though it's the best price performance. So therefore, we're willing to pay more to do this other way, right? But most of the time, you're right, and it's price performance, right? Which is really use case dependent.
I guess kind of for me, I'm curious about price performance and how you tune it, and then I'm like, I've always been curious. I hope this doesn't go too into the kind of the details of like vector indexing and vector search, but this kind of like, you can tune HNSW by adjusting these hyperparameters like EF, max connections, basically like how densely connected that proximity graph is for how you route these queries. And I think it's really interesting with, Weaviate is now has like product quantization, which is reducing that memory by compressing the vectors. So maybe, I hope this isn't too boring of a topic, like for people who aren't super excited about kind of nerding out about how exactly you tune the index for the different computers. But I'm sure that our listeners are interested in that kind of conversation. Like, so how do you think about tuning? Maybe this is a question for Etienne, who's really been, in the weeds of this kind of thing.
Yeah, I'll try to make it exciting. So in a nutshell, these are all parameters that you can tune for a specific trade-off. And typically that trade-off is either index time, query time, or memory footprint. So you mentioned max connections, for example. That's a parameter that literally leads to so HNSW is a graph-based index. Having more connections in the index means more memory, because each connection is essentially stored as a number. You can think of it sort of like the outgoing edges to other nodes are just UN64s or something like that. So this is one of the knobs that you can turn that make the index bigger, but then because it's bigger, it's better connected. It's more sort of, it's easier to go sort of this small world example, I think, that we've used in another in previous podcasts. So if you're trying to go from a person in Europe to a person in, let's say, Asia, then you just need to know someone, I don't know, somewhere in the middle or so. Like, say, have these, like, I think there's this theory that with 5 or 6 or 7 hops or so, you can basically get to any person in the world. And that's the nature of that proximity graph. So the more connections you have, the easier it is to reach your goal with fewer hops. And that's one of those turning knobs. And then, especially in combination with product quantization that you just mentioned. So product quantization reduces the memory footprint of the vector embeddings, but not of the graph. So if you want to get your total memory footprint down, and the fact that you're using product quantization could be an indicator that you've maybe already said on that trade-off of query speed versus memory footprint and therefore operating costs, you're already leaning towards reducing operating costs. So then one way to potentially reduce it further is you could say, in my index, I want to take that same, or do that same trade-off, and I want to trade off a bit of index memory footprint for higher latency. So you say, like, okay, fewer connections which means that the graph footprint is smaller. And then in turn, maybe you have to search for it a bit longer. So this would be the query parameter that you would have to tune. So this gives you the effect on the infrastructure in your cloud is essentially like if you tune this well, you could end up with the same use case either needing 16 gigabytes of memory or maybe 32 gigabytes of memory. And of course, they're not identical. Like you would have, for example, higher query performance on the one with 32 gigs as opposed to with 16. But if you take that into consideration, then it's easier to plan your infrastructure. So you have lots of ways. That said, Weaviate has reasonable defaults. So there is a certain size where all of this tuning doesn't matter. And we try to pick defaults where you can just get started. And probably you'll know when you have to tune them, because you'll either reach out to us or you'll start running into like memory limitations, or you look at your AWS bill and you think like, hey, maybe I can get that memory footprint down a bit. So this is for mainly for the heavy production focused and large use cases. But yeah, it's good to know that you can tune these things if you want to.
Yeah, and so I get kind of like, this is kind of the question that sort of, selfishly I was hoping to get answered in this podcast. Is I've always been, from when I first was learning about Weaviate, I learned about horizontal scalability, kind of, and I think I have a rough understanding of how you shard each of these kind of classes, and then how you scale out shards across machines. And so, yeah, I'm just so curious to hear your perspectives on how scaling out machines works in the cloud, particularly, in this setting where you're running like a Weaviate cloud service in AWS. And so Weaviate has something like, again, I understand this a little bit, so I'm trying to my best to set up the question, but like, I know you kind of have things like Kubernetes where you have like, here's kind of like the code for how you would scale up to more machines. So yeah, maybe you guys could take the baton from here. Like, how are you thinking about like how Weaviate can have a service that then within AWS would say, okay, we need, 8 32 gigabyte RAM, that kind of thing.
So I'm going to set up Etienne for this question. I'll give like the high level answer, and then I have a feeling you're going to know the very detailed answer, how this actually works in your use cases that you've seen. So at a high level, AWS offers something called auto scaling, which is basically like horizontal. Like vertical scaling is when you basically like increase the horsepower of your instance type, whether that's like bigger GPU or more RAM, whatever. Horizontal is basically you add more instances to do whatever you're trying to do. And if I recall from my ASA days, this is like the Associate Solutions Architect course that you can take to learn more about AWS. You can do things like monitor like your CPU usage or your memory usage as triggers to know when to do some horizontal scaling. So now I'm going to pass the mic to Eden to talk about like, well, what things do you monitor to do horizontal scaling? What are the things you look for? How do you actually architect it using orchestration? Like you touched on Kubernetes, right? Kubernetes is one way of containerizing and then doing scaling. But yeah, I'd love to hear like, what are the specifics of what you see customers do?
Yeah, Kubernetes and Weaviate are kind of intertwined in a way, but also they're not. So there's nothing in Weaviate that will make it Kubernetes specific, but it's just one of the operations decisions where we said like, you get so much for free with Kubernetes service discovery, scaling, rolling updates, like all these kind of things that we said like, this is just how we want to run Weaviate. Technically, you don't have to. You could just spin up manual EC2 machines or so and just build it that way. On the sort of cluster architecture / design part, what's sometimes a bit difficult in vector search is that indexes are hard to split up once you have them. So sometimes you're actually forced to do vertical scaling, which you kind of want to avoid because, well, if you have replication, then at least you can do it with zero downtime. But it's way easier, of course, to do horizontal scaling. And one way that you can achieve that with Weaviate is the multi-tenancy feature, because the multi-tenancy feature schedules each tenant. So each tenant is essentially like a lightweight shard in Weaviate. And each of those tenants is scheduled on exactly one, or if you spread it out on multiple nodes. But that means the next time you add a tenant, it can be scheduled on a new node. So if you would say your load is, let's say you have a multi-tenancy application, someone can sign up for your, let's say personalized chatbots. Like a user can sign up, can upload documents, and can chat with their documents. And then you have 10,000 users. Then each of those, your users would be represented by one tenant in Weaviate. And of course, these 10,000 users, like the moment you start using Weaviate, you would have some of them, but your goal is to sign up more of them. So ideally, you add more users every day. And this is where it gets really interesting, because at some point you're going to run out of space, and then you can very easily scale horizontally. You can just say, okay, add more nodes to the cluster, and then all your new tenants that you sign up from that point on, they will be scheduled to those new nodes. And that gives you basically infinite linear scaling for the number of nodes. One thing that's not released yet, but that's currently on our roadmap, is then also to rebalance this and redistribute this. So right now it's like once it's scheduled on a specific node, it's fixed. But that is an upcoming feature as well, to then give you more control over moving that data around. And this is one of the common cases that we see where people basically use horizontal scaling to increase the capacity of their vector search cluster.
Yeah, I mean, that's perfect. You couldn't ask for a better way to scale than aligning your horizontal scaling with number of users, right? So that's perfect.
Yeah, that was super interesting. I love that kind of, yeah, the way that you firstly separate, horizontal scaling and tie that with multi-tenancy, and then compared to vertical scaling when you need it because of the vector index. I think, the cloud service that orchestrates managing that for large apps, I find that all to be so fascinating. And kind of like one other topic I'm very curious about, it's kind of related to this idea of having like a product that manages cloud services, is kind of what becomes different when you're running it like privately. Like, we see this with like, just as a random example, last night I attended a generative AI and healthcare meetup in Boston, and they're all, we need to run this privately. So like, what does that mean from the perspective of AWS? I understand it's like public cloud. I can just kind of like go to EC2 and get running. How does Amazon or AWS think about private cloud?
When you say private cloud, I just want to make sure we're talking the same page here. Are you referring to like someone owning like a data center within a colo? Or are you talking about like something where, hey, this needs to be all happening within my VPC, within my own cloud, single tenancy for this one company? Everything does not leave this thing, right? So are you, which one of those two are you referring to?
I'm certainly interested in both. I think like kind of as I mentioned that like healthcare in Boston thing, the latter probably sounds like that case where you're, really like nothing can leave here. And I think the other thing that's really an interesting part of this topic is kind of like having the LLM, the large language model, as well as the vector database both be in that kind of setup together. I think.
Yeah, we can talk about both of those. So let me talk about the latter first, because this is where I do talk to my customers about, and I'm certainly happy to share like a perspective of what I'm hearing about like colos and data centers. So as far as AWS and keeping things extremely private, let's kind of walk through like a little mental model of what an architecture could look like. So when you're using AWS, you can use you can use VPCs, right? And within a VPC, like you can be totally isolated from the rest of the internet or even other AWS users, right? Um, in that context, you can easily have your vector database be in there, right? So everything's within your VPC, right? Whatever instance you want to host Weaviate on, for example, can be there. And then the question becomes, well, okay, let's say that I want to make sure that my prompting never leaves my VPC either. I don't want anyone to see my prompting, and I don't want anyone to see the responses from that prompting, right? Um, the first level of like standard security that you can do is by using like a service called, like I mentioned earlier, Amazon Bedrock. With Bedrock, the way that it works is you effectively get an API within your VPC, and it can be set up in a way where basically via private link, it connects to where the model is hosted, which means you can't see the weights of the model. But because it's private link and it's single tenancy, this is all things you can configure with AWS. What that means is nobody else gets to access that stuff, right? So you can almost think of it as like you have your VPC bubble and it kind of extends out to another cluster somewhere, but it's all single tenancy. No one else gets to see it, and it comes back to you. So in that scenario, everything's completely private and it's only for you. And we have customers that, like, for example, have FedRAMP security standards that they need to reach, right? So I just talked to a customer this last week that's using a different service called Amazon SageMaker Jumpstart, where you can host models in a similar fashion within your VPC. And let's say, for example, you wanted to use Llama 2, right? With Jumpstart, you would provision some instances for your SageMaker endpoint that your vector database can interface with, and that endpoint, you get to decide what type of instance that is, right? So for example, you can have Llama 2 hosted on A100s, you can have Llama 2 hosted on Inferentia 2, and you manage that. But what we do for you as a user is make sure that that instance is single tenancy, and you're the only person touching that, and no one else gets to see that. So you're now completely containing how you're interfacing with these LLMs, whether or not they're proprietary or open source. Right. And this does come up quite a bit. And when I was making the comment earlier about like price performance and sometimes security, this is basically what I was alluding to. Right. Like, so if for example, a customer, most 9 times out of 10, customers like, I'm going to, as long as everything is done via Bedrock and I know that it doesn't go to the model provider, I'm happy security wise. And then let's just focus on price performance. But like, what if a customer says, no, I need an additional layer of security? Then maybe for some reason they have to use SageMaker Jumpstart because there's more knobs there, right? And at that point, it goes back to price performance. And in the case, a lot of times what I see is like, a lot of times, these models are pretty large. And that means you have to use pretty beefy, pretty large instances to hold them, right? So I don't know how much, off the top of my head, like how much memory Llama 2 takes for the 70 billion, but there's a good chance that you either have to run it on A100s or Inferentia 2, right? So if that's the case, like these are beefy instances, they get expensive. So you better, and this is where you start to think about, well, maybe we should use the 13 billion or the 7 billion parameter version, right? So this gets in the whole price performance thing, right? You're always working backwards from use case, but basically everything works backwards from a privacy perspective. Keep everything within the VPC, nothing leaves. That seems to 9 times out of 10 address security concerns from customers. There are other use cases. So now let's go into like the whole colo data center part of the question. There are customers that have data that they just cannot put in the cloud, period. It cannot leave their own data centers, right? So in those use cases, obviously I don't have as much purview into that given that I work at AWS, but in those use cases, these customers tend to buy like pre-made clusters from other companies, which may or may not be elastic. That part I'm not sure about. But I'm pretty sure that, if you're a super large company that owns their own data center, you're probably going to find ways for it to be elastic. And I have no reason to suspect that they couldn't do horizontal scaling in that type of environment as well. But I think that most companies are able to use LLMs in the cloud, with the exception of companies that have data that cannot leave their own on-premises data centers.
Yeah, no, that's really amazing. And firstly, thanks so much, because I hear that question a lot too. And now I feel like I have a good answer. I think it's also interesting whether you need the vector database private or the LLM private or both, and kind of maybe some nuances around that. And yeah, I think this kind of like single tenant, all that kind of thinking around how you do this thing. Yeah, all that's really interesting. Etienne, I'm curious if maybe you have some thoughts on like, that kind of like tenancy and the VPCs as Farshad describes.
Yeah. So with tenancy, because I talked about multi-tenancy before, but in a very different context. So it's kind of a difficult term, because before, multi-tenancy referred to our users having multiple users. In this case, now tenancy refers to sort of the isolation boundaries within AWS. So let's say our chatbot application from before is an AWS customer. They don't want their data to be mixed up with competing chatbot application, but still within sort of this single tenancy setup, they might have multiple users. So it's a term used in multiple settings. Nevertheless, the concepts are exactly the same for us. So data that shouldn't leave a certain realm. And this is something where the sort of, again, those using the same term, the single tenancy nature of your own Weaviate deployment in your private VPC, in your cloud tenant, that gives you the capability to stay completely in control. So we touched upon this at the very beginning. If you want just something fast, up and running, just use our Weaviate cloud service. Or Weaviate cloud service in that definition of tenancy is multi-tenant. So that means other customers that use the Weaviate cloud service run in the same AWS project, for example, on our cloud service. If you have these requirements for strict isolation, you can run it in your own, we say in your own VPC, and the VPC is in your cloud tenant. So it's basically whatever kind of boundaries you want to define. And you can do this. This is something that we're launching right now as we're recording this. It's not public yet. Maybe it will be when we're depends on how long it takes to edit this. Or we're just about to launch on the on the AWS Marketplace. We're launching Weaviate on the AWS Marketplace, and it's a one-click deployment kind of setup where you can do exactly that. So if you have an existing VPC, you can deploy into that VPC. If you're starting from scratch, you can create a new VPC, and this is the kind of setting where you can make sure that, because your data that's contained in Weaviate is then wherever Weaviate is deployed. So exactly the same concepts. It can never be accessed by anyone else. It can never be mixed up with someone else. No one else has access. You are completely in control. If tomorrow you decide you want to tear it down, you want to delete the disks, you are in that kind of control, which is great for all kinds of security, compliance, etc. settings. The downside basically is that it's potentially a bit more operations effort, because now you're running Weaviate, and this is where our hybrid SaaS idea comes in. So with hybrid SaaS, basically the Weaviate team helps you run this. So depending on how much data you're willing to give away, for example, one thing that you could opt into is saying like, hey, I want to push my metrics to the Weaviate team. Then what we can do is monitor the metrics. So you can say like, hey, you're about to run out of XYZ, or we see a pattern here or there, or maybe if something happens, then you're reaching out for support to us, then we can say like, yeah, okay, we have the kind of diagnostics tools that we need. Or another option is like, even if you can't even share metrics, then we can also in the sort of least common denominator would be we can jump on a Zoom call and maybe sort of figure out what's going on together. So you get like various levels of support contracts and support settings in that kind of hybrid SaaS setting, where the sort of underlying thing is you own your data and we help you with the operations part as much as you want.
Yeah, I could see a lot of customers wanting to use the marketplace option you're talking about, where it's within the customer's VPC. I would love to do a blog with you where we show customers how easy it is to do, and maybe like a use case that it works really well for. Because I think a lot of customers would appreciate that.
Awesome. Let's do that.
Yeah, amazing. I'm sure all listeners to the podcast are going to be excited for that blog post as well. And so kind of one, Etienne, you mentioned, Weaviate on AWS Marketplace. I think that's one of these big headlines with our podcast and like something we're super excited to announce. And Farshad, I'm just really curious, like, like Weaviate, the startup and now being on the AWS Marketplace, if you can maybe talk us through like, what does it take to get your cloud service on the AWS Marketplace?
What does it take to get your cloud service on the AWS Marketplace? Well, technically, Eden knows more than me now, since he's actually gone through it. But at a high level, AWS has so many different ways to partner with basically companies or startups. And what we do is there's two methods, maybe more. One method is through AWS Marketplace. Marketplace basically makes it easier for you to consume partner products and services through AWS Marketplace. And what's kind of interesting is that if you like have, contracts with AWS Marketplace can actually count towards that, right? So in other words, there's incentive for companies to go out there and to use Marketplace to consume things. Rather than going directly to, for example, Weaviate, right? So in other words, there's incentive for me to consume Weaviate through AWS Marketplace and to go directly to them, right? And it makes things easier for billing reasons, right? You go through one place to do everything. And the process for doing it is basically you apply. If I'm not mistaken, you can also in parallel be a part of the AWS partner network if you choose to. And that has two categories. One is consulting and one is a technology partner. You can think of consulting as like, hey, you can hire our developers to help you build whatever, whether that's infrastructure or app level, and we can do that. And then at the technology level, it's basically like SaaS things, right? So we, for example, be a technology partner and be on AWS Marketplace. It's not necessarily a difficult process, but there is like a process of going through like architecture reviews, making sure things are set up and meeting standards with AWS. And the most important thing I would say is like if you're a company thinking about APN or marketplace, I've never. I'm going to speak anecdotally here, right? I have to be careful here. It's not a you do this and you get additional revenue. It's not the way to think about it. The way to think about it is this thing. You've already got a fire. You've kindled your fire. It's going, and this thing is fuel. It will scale you. It will add much more opportunities to your existing opportunities, right? And the way a lot of enterprises think about this is you make it frictionless for me to consume your SaaS product. You're making it frictionless, right? So if no one's ever heard of you before, it's going to be very difficult for Marketplace to magically get you new customers. But if you already have a presence in the world, an enterprise can say, oh, and you're in Marketplace, so this is going to be easy for me to consume you. That's how you should be thinking about it, right? So it does work, but there's like a level expectation of how it works. It's important to consider. We have a lot of companies that make a ton of money off of Marketplace and APN. It's very successful for them. But what I don't want to do is mislead someone and say, you do this and you magically get revenue through AWS, right?
Yeah, that perfectly matches our experience. I think the motivation to onboard into the marketplace was because we had customers asking like, hey, I would love to buy this through the marketplace, but you're not on it. Can you get on the marketplace?
Yeah, exactly.
Awesome. Well, Eddie and Farshad, I love this podcast. I think it was such a great tour, beginning with kind of trends in vector databases and retrieval-augmented generation, stepping into this, machine provisioning, horizontal scalability, multi-tenancy, all of these cloud stuff. It's so amazing. So both, thank you so much for joining the podcast and sharing this knowledge. I learned so much.
Thank you both. Super fun.
Yeah, same here. Thank you.